Imagine discovering a diary from Earth's first day, a record of our planet's origins. These ancient rocks are time capsules, holding secrets about how Earth formed, how continents grew, and how life began. They're the first page of Earth's autobiography, stretching back billions of years. Each rock tells a story. Volcanic rocks reveal Earth's fiery interior. Ocean rocks tell of ancient seas. But the oldest rocks tell the most epic story. Before oceans, before life, before air. By studying their chemistry and structure, scientists reconstruct a picture of a young, chaotic Earth. This quest has led researchers to remote deserts, icy plains, and most notably, northern Canada. There, in the wilderness, lie rocks that may be the oldest pieces of Earth's crust ever found, challenging everything we thought we knew. Why does this matter? Because these rocks hold answers to how our climate formed, where our water came from, and how life's conditions arose. Unlocking their secrets deepens our understanding of our place in the cosmos. The story of these rocks is the story of us. And it's a story still being written. The search for ancient rocks is a search for our own beginnings. Let's travel back 4.5 billion years to the Hadean Eon, Earth's fiery infancy. The planet was a molten, chaotic world, bombarded by asteroids and comets. No continents, no oceans, no breathable air, just a glowing ocean of magma. The moon loomed much closer, stirring massive tides in the molten surface. Over hundreds of millions of years, Earth slowly cooled. A thin, unstable crust formed atop the magma, but it was constantly broken and recycled. Almost all of this original crust has been destroyed, making any surviving piece a geologist's ultimate prize. The Hadean Eon is Earth's greatest mystery box. Few rocks remain, and each grain is a message from a lost world. Did life begin in this chaos? Did oceans form only to be vaporized again and again? These questions drive the search for the world's oldest rocks. The Hadean set the stage for everything that followed. We're only beginning to unlock its secrets. Each ancient rock is a rare clue to our planet's wild beginnings. The journey to understand them is just getting started. In northern Quebec, Canada, lies the Nuvvuagittuq Greenstone Belt, a geological treasure. This remote, rugged land has been home to the Inuit for centuries and now draws scientists from around the world. Greenstone belts are ancient seafloor rocks, colored by minerals formed when volcanic rock met cold seawater. They're found in the oldest parts of continents, telling stories of early volcanic activity and land formation. The Nuvvuagittuq Belt, or NGB, stands out. Its rocks may be the oldest ever discovered. These rocks are remnants of ancient volcanic islands, including lava flows, ash beds, and ocean sediments. They offer a rare snapshot of Earth billions of years ago. First mapped in the 1960s, their true significance wasn't realized until decades later. Scientists began to suspect these rocks were older than any others on Earth, sparking intense research. The NGB became a hotspot for geologists seeking answers about our planet's earliest days. Here, the quiet landscape hides a groundbreaking secret. These rocks could be the closest we've come to touching the dawn of time. Their discovery has changed our understanding of Earth's history. The Nuvvuagittuq Greenstone Belt is a window into our planet's deep past. How do you date a rock billions of years old? Not with tree rings, but with radiometric dating, a natural atomic clock. Some elements are radioactive, decaying into stable forms at known rates. Uranium, for example, decays into lead over billions of years, making it perfect for dating ancient rocks. Scientists extract tiny zircon crystals from rocks, which trap uranium but reject lead. By measuring the ratio of uranium to lead, they calculate the rock's age. If there's more uranium, the rock is young. More lead means it's ancient. But the Nuvvuagittuq rocks lacked zircons, so scientists used a different clock, neodymium and samarium isotopes. This method is more complex and controversial, but it allowed them to estimate the rock's age. Dating ancient rocks is scientific detective work, sometimes requiring creative solutions. Each method brings us closer to understanding Earth's earliest history. The quest to date these rocks is as challenging as it is fascinating, and sometimes it leads to scientific debate. Every discovery has its heroes. Here, it's Jonathan O'Neill. As a young PhD student at McGill University, O'Neill proposed that Nuvvuagittuq rocks could be Earth's oldest. He focused on a unique rock called faux amphibolite, which held ancient chemical secrets. Guided by mentors Don Francis and Ross Stevenson, O'Neill ventured into Quebec's wilderness to collect samples. Back in the lab, he and Richard Carlson used neodymium-samarium dating to analyze the rocks. Their results? An astonishing age of 4.28 billion years. When published in 2008, this claim made headlines worldwide. O'Neill's work pushed back the known age of Earth's crust by hundreds of millions of years. The discovery was a testament to curiosity, persistence, and teamwork. It sparked new questions and inspired further research. The Nuvvuagittuq rocks became a focal point for early Earth studies. Sometimes a single idea can change our understanding of the world. Claiming to have found Earth's oldest rocks invites intense scrutiny. O'Neill's 4.28 billion-year age was thrilling, but controversial. The debate centers on dating methods. Without zircons, the team used samarium neodymium dating on whole rocks. Critics argue this might date older material melted to form the rocks, not the rocks themselves. To test this, another team found tiny zircons in a different Nuvvuagittuq rock and used uranium-lead dating. Their result, 3.77 billion years, still ancient but 500 million years younger. How could one belt have two vastly different ages? Some say the faux amphibolite is truly oldest, others believe the younger zircon age is correct. The debate continues, pushing scientists to refine their techniques. This is science in action, testing, challenging, and searching for truth. The mystery of the Nuvvuagittuq rocks remains unsolved, but every challenge brings us closer to understanding Earth's beginnings. The search for answers drives geology forward. How did any rock survive over 4 billion years on such an active planet? The answer: location and luck. The Nuvvuagittuq belt sits in the Superior Craton, a stable, ancient core of North America. Cratons are geological fortresses, thick, rigid, and undisturbed for eons. Protected from violent processes like subduction, these rocks avoided destruction. They weren't buried too deeply or cooked by intense heat, preserving their ancient chemistry. Most early crust was recycled, but these rocks endured. If their age holds, they're a rare remnant of Earth's first skin, protocrust. The Nuvvuagittuq rocks challenge the idea that all early crust vanished. They're a priceless window into a lost era. Their survival is a geological miracle. The Nuvvuagittuq rocks reveal profound truths about early Earth. Their existence suggests Earth's crust, and possibly oceans, formed quickly after the planet itself. These volcanic rocks formed underwater, hinting at ancient seas over 4 billion years ago. Water is essential for life, so this pushes back the timeline for habitability. The rocks may even contain evidence of the earliest life, tiny hematite filaments resembling those made by modern bacteria near hydrothermal vents. If confirmed, these would be the oldest fossils ever found. The claim is debated, but if true, life appeared almost as soon as Earth was cool enough. These rocks are more than geology. They're at the heart of the search for life's origins. Each discovery rewrites our understanding of when and how life began. The Nuvvuagittuq belt is a key to Earth's earliest biological history. Its secrets are still unfolding. The Nuvvuagittuq Greenstone Belt is not just a scientific site, it's the traditional homeland of the Inuit. For thousands of years, the Inuit have lived with and respected this land. Scientific research here must be done in partnership with local communities. The Inuit, represented by organizations like the Makavik Corporation, are stewards of this unique place. Protecting the environment and cultural heritage is essential. Scientists must consult, obtain permits, and ensure research benefits the community. Inuit traditional knowledge enriches scientific discovery. Working together blends modern science with ancient wisdom. The future of Nuvvuagittuq depends on trust and collaboration. Balancing scientific value with local rights is crucial. The next chapter will be written by both scientists and the Inuit, together.